So, hi guys, everyone, good evening. So, today this is the course content which we had published and we had seen in the last class also. Okay, now the data warehousing concepts is the introductory class where we go about what is the data warehouse, what is the data mart, OLTP, OLAP, different kinds of data warehouses, right? And dimensions, facts, star schema, snowflake schema. We'll go about all those topics. So probably that is what I'm going to cover today. And once at the end of the class, I'll circulate the PPT to you so that you can go and study. And if any questions, you can ask me in the next class. So once this data warehouse is complete, probably I'll take 1 or 2 people at once and try to install software on your machines, right? So it is about 2.5 GB software. I'll give you the Dropbox links. So you have to download it and let me know, and then probably 2 people at a time. I can call you. We can have a slot, and I'll start installing one by one. Okay. So that is the next step which we do. Once the software is done, I'll start with Informatica course, Informatica architecture, and then slowly moving to sources, targets, different kinds of transformations, mappings. That's how we progress. I mean, as the content says. Okay, so this will be the thing for the next 1 week to 10 days. Now, I'll definitely tell you the topic, what topic I'm going to discuss the next day. Okay, so that if anybody is interested, you can visit blogs. If you already know it, you can revise it and come back to me so that the discussion will be fruitful. So that's all I'll generally do. Now, let's start with data warehousing. Vidya, you said your requirement. I did not get it. The testing quiz requirement. Okay, fine. Okay, so the definition of data warehouse is something like this. It's a subject-oriented, integrated, non-volatile, and time-variant collection of data in support of management's decisions. Okay, so let's try to understand what does each term in this definition mean to us. So what is subject-oriented? When I say subject-oriented data warehouse, for example, you take any bank or you take any firm. How is the data warehouse built? So the data warehouse is built primarily on the subject areas they do. For example, if you take a bank, consumer is one big subject area for them. Probably business banking is one subject area. Loans is one subject area. Auto meaning all the car loans is one subject area, right? They take different subject areas. Or if you take a basic example like any school or a college or a university, if you're going to build a data warehouse for a university, what will be the major subject areas for them? Probably accounts. Accounts is one subject area. Similarly, student admissions is one subject area. And what else? The staff and other things like books. Probably they might be categorizing into different subject areas based on the business they do. So a data warehouse is always a subject-oriented one. Okay, and as I say, you can categorize into different subject areas based on your need and your business requirement, whatever it is. Now, it is also called as integrated. When I say integrated data warehouse, in one single data warehouse, which is subject, you can have multiple smaller subjects in it, which are also called as data mart. I'll come to it, what is a data mart. But yeah, if you see the screen, the example shows account is one primary subject area. Okay, so in the account, you will have 3 other three other subject areas, which are like savings account, loans account, checking account, or an trading account, right? Trading account and checking account, I think, are similar, but current account. So different kinds of accounts you can have under one single primary subject area again. So it's again integrated, right? Now, non-volatile. Non-volatile meaning generally in a data warehouse, we don't delete the data on a regular basis. Okay, in a traditional operational system. So what does traditional operational system mean? So traditional operating system is our database, regular database, right? You take any database, what all we do? We do create, update, delete, insert statements, and we always delete the data and insert data. When it comes to data warehouse, we generally don't delete the data. By saying that, people might ask me, so data warehouse is something like we'll have history for ever and ever? Yes, almost like that. But these days, with the increasing data limits and increasing capability and IT people are reducing the cost. So what they're doing is they're implementing some purging mechanism inside data warehouse. So in data warehouse, the deletion of data is directly and is not happening directly. So they call it in a more sophisticated manner called as purging of data warehouse. When I say purging of data warehouse, it means that how do I delete data from a data warehouse? Okay. So by saying this, I'll pause for a second. Any questions on these three? Subject oriented, integrated, non-volatile. I'll talk about purging. Any questions, please?
Yeah, this is Arvind. My question is, what is the difference between data warehouse and database? In some instances, are they same or?
Exactly. That's so good. So a data warehouse and a database, they both contain tables in the bottom, right? The basic entity is tables. And a data warehouse contains tables, but database also contains tables. The only difference will be in your dimensional modeling, which might not be present in database. So in a database is just a collection of tables, whereas data warehouse is a collection of tables with a proper dimensional modeling and also proper architecture, which can easily be accessible in the future. And your data warehouse is also broken into multiple smaller sections called subject areas or data marts, whereas your data, if you have to break databases, you have to probably create schemas, but that is not an efficient way of doing it. Okay, so data warehouse and database primarily differ in two things. One, the dimensional modeling, which will be absent in databases. Second, the star schema and snowflake schema, which we'll talk about in the future slides, that is also absent in database. So these two are the primary distinguishers between a database and a data warehouse. Okay. Now, if you ask me, if I do dimensional modeling inside database, if I do all these facts and dimensions, will my database become a data warehouse? Yes, sir. It becomes a data warehouse. That's it. Nothing else. You will have a difference between database and a data warehouse. Okay. Clear?
Yeah. Thank you.
Yep. And probably adding. Yeah. Good.
So by database, you mean the traditional RDBMS database,
right.
which is used mostly for OLTP applications.
Exactly. It's a traditional RDBMS database which is used mostly for OLTP applications. And also you see, when I call database, it starts from a very minor thing. Even Excel has a database, right?
Okay.
Where it can store. You can use Excel also for storing something. You can use flat files also for storing something. So all these are collection of data. So or you say Oracle or Teradata, they are also databases. But the same when it comes to data warehouse, it is more organized. How it is organized, we'll see it in the slides.
So at a base level, even a data warehouse is a database.
Yep.
And normally,
yes, is a collection of tables.
Yeah. So okay.
Slide 4. Yes, madam. What is sales data in data warehouse? So sales data is nothing but, for example, you are doing some data warehousing for any business who is buying, and suppose Apple. Okay, take an example of Apple. What will be the customer data for Apple? All the customers of Apple. Sales data, whatever he is selling, iPads, iPods, whatever it is. So sales data is nothing but the sales of all the sales is doing on a month basis or anything. So that is subject area. Yeah, business, yes. So subject areas are based on the business you do. That's what I was saying. Account, business, student, if you have student data is one subject area in a university. If you take a bank, loans is one subject area, something like that. Okay, any more questions? Subject oriented, integrated, non-volatile. Okay, so when I say non-volatile data warehouse, right, I said purging mechanism. What does purging mechanism do? So purging mechanism is nothing but people do purging in two ways. Some people will definitely do a soft delete. Some people will do a hard delete. What is soft delete and what is hard delete? So hard delete is nothing but they directly delete the data from the data warehouse using some some mechanisms like delete and truncate mechanisms, right? The same mechanism, but after a period. For example, I think in US, if any customer is leaving a bank, still the bank needs to hold his records or his transactions for the next 7 years, right? So this is called as retention mechanism. So this retention mechanism, as per US federal regulatory rules, is 7 years. So after 7 years, even though the bank deletes data, it's fine. So what does generally these banks do? So they'll probably delete the data after 12 years or 11 years. So that's how they keep on purging it. When they delete the data, some people who wants to still have it, they will compress this data using higher compression algorithms, and they will store it at a secure place using tape drives or something. Some people will directly delete the data if they feel it is not necessary. Clear? The purging mechanism?
Yeah, I think also in US, the bank statements are only available for 1 year from the current date at any given point. If you need bank statement from 2 years back for a current account, you have to request it, and they will get it from a different source, and they will send
No, that is between OLTP and OLAP. I'll come there. Even in India, it's the same. So 6 months, you directly get it online. After 6 months, you have to go and request in the bank. They'll take 1 day or a few hours to get it out. Why? I'll explain you.
Okay. All right.
But this is something about complete deletion of data. So soft delete meaning, Vidya, it is not soft delete meaning I'll delete from data warehouse, but I will still keep it in a tape drive. That is called a soft delete. Hard delete meaning I'm directly going to delete it forever. Okay. So soft delete and hard delete in the purging mechanism. Now, time variant. As I say, how many years you are storing the data for. So the history or the number of years you are trying to store the data is called as time variant collection. So when I go back to definition again, it says a data warehouse is a subject oriented, integrated, non-volatile, and time variant. So these 4 attributes. Subject oriented meaning different subject areas. Again, integrated meaning multiple subject areas can be clubbed into one. Non-volatile, there is no deletion criteria. Only purging is available, that too in some cases. And time variant, storing the data for a longer period, like years and years and years. So if you have to have all these attributes, and you need to build a data warehouse. So a data warehouse is nothing but a subject-oriented, integrated, non-volatile, time variant collection of data, the last line, in support of management decisions. So any organization, primarily they build data warehouse to take some decisions out of it. Decision support system. How does data warehouse help them in taking the decisions, right? So if you're collecting the data for years and years, the data will generate some reports out of it. And based on the report, a CEO can take a decision, can take any decision on how his company is doing, or how are the sales of his company, what best he can do to improve the sales, right? So your data warehouse is definitely used in building some crucial decisions on the top level management. Any guy will not build data warehouse, or any company, if they don't want reporting, there is no data warehouse. I mean, there is no meaning in building a data warehouse out of it. So if you have a data warehouse, definitely you'll have a reporting mechanism on the top. Okay. When I show the architecture slide, I'll talk it in more detail. But any questions till this point? Okay. Good. Now, I'll tell you an example. If you heard of Steve Jobs' statement 4 or 5 years back when iPad 1 or iPad 2 was launched, he gave a statement. In the next, once the iPad is launched, in the next 24 hours, he gave a statement saying that I am able to sell an iPad across the world, each iPad for every 3 seconds or 1 minute. That was the statement he given in a paper. So how can we make that conclusive decision that he's able to sell each iPad every 1 minute? So that is again out of data. So every time you buy an iPad or iPod, anything, Apple has a real-time data warehouse. Meaning once you buy it at any store, it will immediately insert a row in the corresponding data warehouse of Apple. So out of these all transactions which is coming across the globe, he made some conclusive decision out of a report saying that at least for every 30 seconds or 1 minute, he's able to sell one iPad across the world. So for people like me or you who are wanting to buy iPad, if you hear that statement, you'll go crazy. Oh my God, then it's a big hit. We have to go and hit the store right now. So that's how the statements given by CEOs make a crucial impact on the business side. Okay, so those decisions they will be able to take only out of a data warehousing reporting mechanism. Okay, good. Okay, now so there are two kinds of data warehouse generally we do: OLTP systems and OLAP systems, online transaction processing and online analytical processing. So if you look at those differences, right, the major point is OLTP systems hold current data or transactional data, whereas it is used for only end users. It doesn't store the history much. It is useful for day-to-day decisions. The response time is very quick. OLTP attributes. What is storing current data? Storing the data for a lesser period of time. It is useful for day-to-day decisions. Response time is very quick. Whereas OLAP, exact opposite. It holds all the historic data. The response time is slow. And what else? It is useful for the DSS, decision support system. Okay, and stores detailed and summary data. So, for example, if you are going to establish a bank, what kind of data warehouse you choose? Question to you folks. OLTP or OLAP? As I'm going to start a bank.
OLAP.
OLTP.
Okay. If you take,
you need both basically, but OLAP is more useful.
okay, you need both is the perfect answer. But can you explain me why?
Because on a daily basis in bank, people deposit money, people take out money, and if you don't have the day-to-day current access, then people's account will be overdrawn, and it will be difficult to maintain the positive balance in the account. And
Okay.
for historical purposes, if somebody wants to look at a statement 3 months back, 4 months back, and like create a pattern of spending or pattern of things that you buy at different places, then for that purpose you need OLAP.
Okay. Good. I mean, almost there. So, in a simple thing, right? All your OLTP systems, basically your ATMs, your internet banking, they hit OLTP system, where the response time is important for us. For example, if I go for an ATM, it takes 10 minutes, I'll be frustrated. So it should be within seconds. And even the update should be happen in the data warehouse or in the corresponding table at the same point of time, right? As you said, the amount might be overdrawn. So in those cases, we cannot take time to update the records. So there, the speed matters. So I should have a very quick response. So there, the customer-facing systems, all the customer-facing systems will be in OLTP, and all the backend systems will be in OLAP. So the data will be again moved from OLTP system to OLAP system on a monthly basis or on a bi-monthly basis or on a quarterly basis, right? It all depends on the storage mechanism that each bank has. Most of the banks do it on a quarterly basis or half-yearly basis after 6 months. For example, in India, ICICI Bank, it does it every 6 months. Because how do I know it? If I open my ICICI Bank statement and if I am able to do it, I will be able to do it for only 6 months through online, through the web or the login, internet banking login I have. After 6 months, I have to go to the bank and request them. So if I go to a bank and request them, it will probably take 24 hours for them or at least 5 to 6 hours to generate a statement and give it to me on paper. Okay, so that's how, so there, if they're taking time, they're hitting the OLAP system. So they have to go to OLAP, get a query on the corresponding tables and get me the statement back. So it takes some time. Whereas the OLTP systems are fast, they'll immediately generate the statements for you. Any questions?
I have one question. So this loading the data from OLTP to OLAP, does it need ETL?
Moving the data from OLTP to OLAP, not loading.
Not loading. Okay.
I just move it. Okay.
Okay.
It's done through ETL sometimes, done through direct database stored procedure sometimes. So when it is already in database, right, we generally don't use ETL much. To answer your question, we probably try to use stored procs, which is more faster and efficient in moving the data. Okay.
Because the data already has the format.
All that has the format and it is already sitting in the database.
Yeah.
If you have to again use the ETL tool, it has to extract from this database and put it into other database. So the time consumed will be obviously higher.
Yeah, that's true. Makes sense.
Okay. Next one, architecture of data warehouse. Okay. So this is the architecture of a data warehouse. This slide you will see it in many formats. So I majorly customized it so that we'll have the required things which are necessary for our discussion. Okay. Probably if you refer to other blocks, this might be as complex as it can. So I simplified it and have put the required pieces which we generally deal in day-to-day life. Now, I put the primary sources of data warehouses like different external sources, might be databases, might be flat files, might be a number of sources on my left-hand side, and the arrow has extract, transform, load. So my ETL process, which is putting the data into my data warehouse systems. Okay, so when I talk about extract, transform, and load, as I talked in my demo session, I extract the data from different sources. I try to transform them, meaning joining them or removing the duplicates or sorting the data or concatenating two columns, all these things. I transform the data and then I load the data back into my data warehouse systems. So that's how I generally do it. And once I load into data warehouse, it is again between OLAP and the OLTP. The below cube is missing OLTP here, folks. Sorry for it. So it should be OLTP servers. Okay, and the OLAP. Now, a data warehouse is again split into multiple smaller data marts. So what is a data mart? I'll just talk in the next slide. But in many firms, what will happen, or in across the world, we create different data marts for each individual entity. Like I say, or on a higher side, if you want, for each subject area, generally we create one data mart. Mostly, the mapping is one-to-one. Meaning, for example, in my current project, I'm working for a banking thing. So we have a auto data mart, we have a credit data mart, we have a consumer data mart. These three data marts are three different bigger subject areas which are doing a data warehouse for my bank. Okay, so credit space has all information of consumers doing different transactions, all those things. Whereas auto is only focused on loans for different sections like home loans, vehicle loans, all those things. And consumer data mart is exclusively all the customers hitting different sections of the bank. So that's how they divide the data into data marts. Data marts are smaller pieces of data warehouse or smaller sections of data warehouse which might be directly mapped to your individual subject areas. So multiple data marts will bring you the bigger data warehouse. So we do data marts for efficient storage of data, for having the security levels correctly. If you have all the data at one place, probably it is difficult to maintain. Okay, so if you separate into different subject areas or different data marts, it is easy to maintain. The security levels can be provided easily. So for all those things, we do data marts, and multiple data marts will club into a data warehouse. Now, being said that, on the picture you see data warehouse and data marts and OLAP and OLTP. Any questions till this place?
This is Arvind. I have a question. Are the data marts interrelated in any way? Like if a customer is applying for a auto loan, home loan, and any other loan at the same time, and they don't have enough credit worthiness or something like that, how is that determined?
So your loan eligibility you are asking about?
Yeah.
So these data marts are definitely interrelated, sir. For example, or I'll tell you a better example. I mean, I have already a savings account. I'm going to apply a loan in the same bank. Now, once I go to a bank and give my loan, I give a requirement for my loan. When I give my account number, right, you should be able to pull from the corresponding data mart and tell me what is my balance or how am I maintaining the balance or how much loan I'm eligible for. So all these are again interrelated between each of them, and there will be some sharing tables or what we say some common tables so that you can pull the information out of them. Okay.
Yep. Thank you.
And they're generally called bridge tables. The word, the exact terminology, the bridge between two different data marts. So they have the primary key of the account number and your corresponding loan ID or something loan key, whatever is the section. So we call them as bridge tables. Okay.
Okay. Thank you.
So everybody understood the question, right? So how do you interrelate two data marts? That was the question from Marvin. No, any questions, please? Can I go ahead? Okay, perfect. So these OLAP and OLTP systems, again, on the end will be used for reporting purposes. So the day-to-day reports, which are pulled daily basis, will be pulled mostly from the OLTP systems, and the monthly snapshots, yearly snapshots, quarterly snapshots are pulled from the OLAP systems. So we use a reporting tool. We do some data mining. Data mining is nothing but, you hear this term a lot. Data mining is exactly analyzing the data or looking at the data, how best you can categorize them in a single report, right? For example, I might have 10-15 tables which are present in different data marts. When I want to publish a report to a business user, I have to understand what kind of data is residing primarily in all these tables. How can I join them, or how can I club them and put them in a single report, or how can I use it for different reports? So if I have to get an understanding of it, I need to do some data mining. So data mining is primarily understanding the data and using them in a better way so that our reports are efficient and fast. So we do some data mining and then generate some reports out of it. Generally, this data mining is done by the BAs, business architects, okay, and the dimensional modeling guys. It's not a developer role, but yeah, slowly a developer might turn to a BA if he wants. So when he's slowly moving to that higher level role, he should be able to do the data mining and give us the exact usage of each table so that we can efficiently use our queries to pull out the reports from those corresponding tables. Okay. So stop me if you have any questions. I'm going to the next thing. So leaving this, I have two other blocks in my slide which I missed. One is that staging area. One is that metadata repository. Any question? Any thoughts on it? What is the staging area? Anybody? Why do you use staging area?
Staging area is basically to apply your mappings and transformations. You bring all the data to one place before you load it back into the data warehouse to check for consistency and make sure.
Why do we do that?
Because you don't want to waste the time for doing the whole ETL and finding out later there was something wrong with the data or something was missing.
So what happens if I directly hit the data warehouse table? Any real-time example you can give me?
Yeah, if the table has a duplicate entry or duplicate ID or something.
Perfect. Then the data will get lost, right? Hello? Hey, am I gone
It
or?
will keep running the loop because the same ID is found in like same.
Okay. So yeah, I'm there.
Hello?
We lost you in between, sir. Okay.
Oh, sorry. Yeah, I was saying if the data warehouse has duplicate entries and when you're trying to query and get the data out, it will be just looping in the same table for a long time and it will crash the database.
Exactly. And even when I am loading the data, the table will be locked. When it is locked, so the business user cannot do any queries on it.
Yeah.
Okay. So that is also a problem for a user to. So that's why we do some staging area. So what is the staging area? See, in India we do mock exams. Probably everybody might know mock MSET, mock GMAT, mock what's IIT, all these things. Why we do this mock? We are preparing ourselves before we hit the main exam. Similarly, staging
pre-final, right?
Yeah, pre-finals. So staging areas are something like a pre-final or a mock area for me. So before I hit the final database, I make sure that my data is correct and good. So I extract my data, do all my transformations and load into my staging area first. Staging area contains generally only 1 day snapshot. So they are truncate and reload. So once they are loaded into staging area, and staging area tables and the data warehouse tables will be of same structure, meaning all the primary keys, all the constraints will be equal. They are just a mirror image. So once the data is comfortable loaded into staging area, I am good that the data is perfect and there are no duplicates or off that sort. Then I'll append this data to my main tables inside my data warehouse. So these are called as staging tables and they are called as main tables or original tables. So when I append this staging, when I append 1 day snapshot to the original table, so I do it again using it, mostly using an stored proc or some other mechanisms. We don't use ETL much there. So ETL is generally used in staging area only. Okay. So once the data is appended, you will use it for daily purposes. Now, your staging area is useful in two purposes. One, all your day-to-day reports can be extracted or can be analyzed from the staging area itself. You don't need to hit the data warehouse for daily reports. Only for monthly reports, for other purposes, weekly reports, you need to hit your data warehouse. So that is reducing the load on the actual data warehouse. One important point. Second point, as Arvind was saying, Arvind, I think, okay, as he was saying, if you have any duplicates or if your data has any problem, whatever problem might happen, it will happen only for 1 day data. For example, your data got corrupted. You have some bad indexes, bad duplicates loaded into the table. So your indexes got corrupted. In such cases, you might have to rebuild the table structure again. So when you rebuild the table structure again, your data will be lost. If that is happening on the main table, you are gone. You cannot take a risk of losing the data. So if even though 1 day of data is lost, it's okay. Still, you will have the sources active. You can pull them again from the sources and load it back into your data warehouse or the staging area. So that is second point. Third point, the business users might be continuously using queries. So you cannot lock the tables for such a longer amount of time. For example, you might have to load 2 million records a day into a table. When you actually use ETL and load it, it will minimum take 10 minutes. 2 million meaning minimum time, say 10 to 15 minutes is a minimum general good time to load 2 million or 3 million. Okay, using Informatica. Why I am so arrogant on Informatica meaning it's very slow. Okay, if it is the same as Ab initio, it will do it within 5 minutes. That is the speed of Ab initio. So if you take Informatica, it will at minimum have at least 10 minutes. Rough time. So 10 minutes you are blocking an user to query it is a big time. So you cannot hold such big amount of time. So these three factors will encourage you in building a staging area and not hitting directly the original tables. Any questions here? Because staging area is very important. That's why I took some time in explaining all these things.
So when is the data moved from the staging tables to the actual tables?
Okay, that depends on your requirement and your generally it happens immediately. Once the staging table is loaded, it will be moved to the original tables also, because we do it all in the offload time, right? We do it, we call it as batch load time. The term when I say batch load time, the time which my batch runs, Informatica batch runs, or actual my job runs. So that will be basically from 11 p.m. to 4 p.m. 4 a.m. EST standard time, which everyone will do. So during that window only my critical loads will run. So I encourage to update the original table at the same point of time. But if you have any particular users also accessing at that point of time, you might select a different point of time for updating the original tables. See, it's business driven, but most of the purpose we do in the same instant. We do in the same mapping. We just call a stored proc using some post SQL, which immediately updates the original table from the staging table. Okay.
Okay. Now also the staging tables and the actual tables, data warehouse tables, normally they reside in the same database?
No, never. They might reside in the same database, but they might not physically be storing in the same server, if you ask me exactly. If one is lost, I'm going to lose both, sir. Right? If I have a problem, if I'm going to drop some 2 or 3 tables in staging area, probably I don't want to hit the original database. So definitely I keep at least 2 different schemas or 2 different databases which are being stored at 2 different places. Definitely not the same database.
Okay.
So when I say that, right, probably other people, when I say not the same database, not the same, it's Oracle meaning Oracle only. I'm not going to use Oracle for staging Teradata for final tables. It's Oracle, but not the same DB instance. Okay. You getting me, sir?
Yes.
No. Yes.
So now, so move data from your staging to your data warehouse, and you would probably have to do some kind of which is if it is a stored proc, it's going to do a remote or whatever that connection to the other database, and then it will try to move the data, right?
Right. Exactly. So was there a question there? I missed it.
No, I was just trying to think how if there are 2 different databases and you're moving data from staging to the actual data warehouse table.
They're not 2 different, so don't call them 2 different databases, right? Call them 2 different instances of database. Better right, term of calling it.
Yeah, right. Yeah, okay.
So how do you validate the data load from staging table to target table? So we don't. Okay, so all data validations are generally done before doing the staging load. Okay. When we move from staging table to target table, we only do a count check. If I have 1000 records in my staging, whether all 1000 records are inserted into my target table or not. Yes, so those kind of checks will be generally done using again different stored proc mechanisms. Once I load 1000 records from a staging table to a target table, probably we'll talk more about it in our classes later. So you just do a count star before and count star after, and you'll validate it. If you have any wrong flag, you'll raise a flag or alarm saying that the count has mismatch. That's how you do. So rest all validations like, yes sir.
But all that is automated, right?
Yes, all that is automated, obviously.
There's no manual process here.
No. All other validations, Sajani, will be done before staging area. When I say all other validations, like you might do a primary key check. You might do whether there are any duplicates in the table. Or if you're expecting a date in a column, is the date coming out of the data or not? Or is there any unwanted characters coming? All those kind of checks are basically done with the help of ETL tool before staging area. Okay, from staging to target, I basically do only the count check. That's it, nothing else. Good questions. Anything? Good discussion. Anything else, please?
Yeah, one last question.
Yep.
For the staging area, is it directly? Is it possible to get reports from the staging area directly?
Yes, it is possible. It should be possible. Then only my staging area has some meaning.
Okay. All right. Thank you.
Right. All the day-to-day reports I can pull from the staging area, which are faster and efficient, because my staging area tables will only have 1 day of data lesser data, your report will be faster. If you think on a broader perspective, right? Any tool you use, if you have less amount of data, the report will be generated in a faster amount of time. Straightforward relation. Less data, the more faster the tool gives the report. From a staging area, it should be a mirror image. The data should be in the same replica. So I should be pulling it from staging area. I should not be pulling it from the main table for a day-to-day report. Clear?
Yep. Thank you.
Now, this metadata repository. So your metadata repository is nothing but metadata, meaning the description or the data about the data. What is data about the data? So when you integrate n number of heterogeneous sources into an ETL tool, one might be a flat file, one might be a table, one might be an XML source. The data definitions among these different heterogeneous sources will be different. Meaning, in my Oracle, I call it as varchar2. In a flat file, I call it as a string. For example, if you take a flat file, I have only two data types there. It might be a string or a number. That's it. I don't have a date there, right? So whenever I read a flat file, I either read it as a string or a number. If it has a string, it might have semicolons. Or it might have, one second. So this is a flat file I assume. If I am trying to write some data here, 1, 2, 3, comma ABC. So I want to represent this as a string. Probably I might have put in single quotes or double quotes. That's it. If I am writing a date also, it will be still a number to me. Okay, something like this. So when it is a table, you will have different data types again. You might have a data type, integer, decimal, big int, all these things. When it is an XML source, you might have different. When it is a COBOL, it is completely different, right? You have COBOL px of 9, px of 16, something like that. So all these data types will define you how the data looks like. When you have something called as a date data type, it means that that column is going to contain valid dates, meaning it cannot contain this date, right? It is not a valid date at all at any point of time because February 31st. So your columns are being identified by your data types, meaning that is the exact metadata information which you are looking for. So all those data type definitions and the corresponding mappings will be stored in your metadata repository. When you integrate multiple sources, so this is how you use your metadata repository. Basically, this comes with an ETL tool, okay? Or some people might use a different metadata generator and the ETL tool different. Meaning there are some MDM tools, metadata management tools separately. Informatica is also an MDM tool. Okay, your Power Center is only the ETL tool of it. So it has a metadata management tool. 1 second. Let me pull out Informatica homepage. I'll show you all the products of Informatica. I'll stop in the next 5 minutes probably, and then I'll continue the next because I know it is your night. So these are the different products of Informatica. You see, data quality, data masking, data visualizing, all blah blah blah. This is that MDM tool which I'm talking about. Sorry, I call it as metadata management or master data management. Both are one and the same. Okay. This is our Power Center Big Data Edition, or our Power Center should be somewhere between here. Where is our Power Center? Okay, so it will be in the Power B2B Data Exchange, and in this arena, our Power Center tool is generally placed. So these are the different tools there. Now, when I talk about this metadata, right? So people might use a different tool for mapping all these different data types into the target data type, so that it will be easy for us. Or they might use the same ETL tool provided metadata manager for getting this kind of information. Okay, that's how metadata repository is also being stored in your data warehousing projects. Clear? Any questions? Okay, good. Now, the next thing. So yeah, that data warehouse and data mart. As I said, generally a data mart indicates a single business process. So based on your different subject areas, I might divide into data marts so that I have easy control and security levels can be provided easily, and basically breaking the data into multiple smaller sections so that it is always easy to maintain for me. Now, a data mart will be having multiple tables in it using some star joins, facts and dimensions. They again follow different kinds of data dimension modeling there. So we'll talk about what is a fact, what is a dimension, what kind of data is stored in a fact, what kind of data is stored in a dimension. And whereas on a contrary, data warehouse is just nothing but its union of all data marts. Okay, that is between data warehouse and data mart. Now, the next thing. So Anthony, it takes another 15 minutes if I continue this topic. It's up to people who hear this whether I want to continue or stop it here. Okay. Anybody has a problem? Probably. Can I continue for next 15 minutes, or you want me to pause it here and continue from there?
No, you can continue. This is all right.
Okay. Fine. I think I did not hear no from anyone. Thank you. So basically, you will in a data warehouse projects or in a data mart. So you'll have two kinds of tables primarily, a fact table and a dimension table. Now, what is a fact table? What is the dimension table? For example, I have these attributes. I generally take student attributes a lot because it is very easy and we come from the same background. Our progress report is a manually generated data warehouse report, right? Probably international schools are trying to build data warehouse out of it. In Hyderabad, we have one. This Chirac Public School, which is in high-tech city, it has a mini data warehouse. So they generate the reports also online. Every school is doing it. So even your progress report is a report which indicates your marks and which is sent to your parents. So basically, let us take a school example. It's very easy, right? Student name, gender, his class, his address, his phone number or parent phone number probably, address, phone number, mother name, father name, what else? His marks, his rank, his percentage, blah blah blah. Rest all details. Now, among these all attributes, dimension table, okay, fine. Option present status, yes. So dimension table will generally contain the attributes which are the dimension table definition is something like this. Dimensions are nothing but which are referential data, or if I have to say in a layman terms, the data which does not change much over a period of time. So those kinds of fields or those kind of entities are generally stored in a dimension table. Now, when I say data which does not change much over a period of time are generally categorized as dimensions. Now, by saying that, so what is the column which does not change much, guys?
Student ID, student name, gender.
Right. Class, if is an intelligent student like me, class is also a dimension, right? It might change once in 3 years, not a problem.
Yeah, father's name, mother's name.
Perfect. And of course, address and phone also, right? So these can be categorized under dimension table. Now, what are my fact table? On the contrary, fact table contains the transactional data, and data which changes regularly. That is the exact contrary definition. Now, what is the transactional data here? My transactional data meaning
rank,
marks. Yeah, marks and rank. Obviously, because that is why I categorize students or I rate the students. So marks, rank, percentage, all these are my transactional data which gives me something out of it. His marks will tell me what is his rank, what is his percentage. So I'm deriving some more attributes out of it. Now, the similar example, if I extrapolate or if I put it to a bank, what happens? I have customer ID here. I have customer name here. and I have one more attribute called as account number probably. Of course, gender is also stored, account number, type of account, all these things, right? And instead of marks, I'll have my balances, credits, debits, and all those things. So my customer ID, customer name, my account number, my type of account, my phone number, my address are my dimensional data for a bank. So it is the customer data which does not change much over a period of time, right? You might update the address once in 6 months or once in a year, but not regularly. Similarly, phone number or the email ID, all these things. Whereas your balances, network, transactions, or your stock holdings per day, they will change daily or they will change hourly based on the amount of transactions you do. So all those attributes will be generally be stored in a fact table. So a fact table contains the transactional data, a dimension table contains the referential data. Why it is called as referential data? Meaning, for example, if we have to pull out a report, okay, you'll first refer the dimension table. What customer ID, what is his name, what is the account number, and then in the bottom you'll put all the transactions and his network. So that's how a statement is sent to a customer from a bank, right? So the dimension table generally holds the referential data, and they're used in joining multiple tables. We'll see when we go to our next classes. And a fact table contains more of a transactional level data, which is used to pull out reports and other business needs. Yes, sir. Any questions? Clear dimension table and the fact table? Okay. Now, this dimension table, fact table screen. Yeah. So fact table contains the transactional data generated of business transactions. Dimension table contains master data or referential data used to analyze transactional data. Now, inside the fact table, you have multiple facts like, inside the fact table, you contain two sections, basically the key section and the measure section. Okay, and measures are again categorized as three things: additive, non-additive, semi-additive. Now, fact table contains two types of sections. So every fact table, you'll have the foreign keys from the dimension tables. Meaning, for example, there is a table called as transactions. Okay, and this is one of the table which we have in our project today. So this transactions contains my customer ID, my account number, account name. These three attributes. Primarily, these three attributes we pull from the customer table, and rest it contains the transaction date, transaction amount, and all those blah 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 details which are related to his transactions. So this is a fact table. So the first three columns are the key columns which are being pulled from a dimension table, or they're being derived, or they're being referred from a dimension table. So your fact table will contain these three columns, only these three, not any more details, right? What is the account type also we may generally store or not store in it. So this is the key section, and the rest are called as a measure section. The measures are the actual fact columns which are related to your business transactions. Any questions, please? Okay. So here, similarly, the key section and the measure section. In this example which I put up, you have date, product ID, and customer ID. For example, you are in a sales background. So product ID, what is the product ID you bought, and customer ID. And similarly, sales revenue, total quantity, unit cost, sales price are the actual measures. And measures are categorized again into three: additive, non-additive, and semi-additive. So additive measures are which you can derive new measures. Basically, you can add two measures and derive a new one. And non-additive, you cannot do in any calculation. For example, percentages. You cannot add percentages. You cannot subtract percentages. So percentage is a non-additive measure. Semi-additive. In some context, you can edit them. Some context, you cannot edit them. So those things are called additive, non-additive, semi-additive. Okay. Any questions, please? Okay. Next. So these tables are basically arranged in two schemas, star schema and snowflake schema. So there are some more proposed by different people, so extended schemas and all these things, but majorly you will have the data or the tables organized only in these two schemas. So here is the place where your exact dimensional modeling or the data modeling comes into picture. So how do you have tables now? You categorized the columns present in the tables as dimensions and facts. So that's what you did. So basically you are having dimension tables and fact tables. Now the important piece is how do you create a link between all these tables, or how are these tables interconnected between them. So that is the most important thing which we have to do. Then your dimensional modeling will be done. So only if a dimensional modeling is built, as I said, it becomes a data warehouse. Otherwise it's a general database. So it's just dumping of all the tables which we do in database, which we might not do this proper interconnection between all these tables. Whereas in data warehouse, there are proper modeling built on the top of it. Now, what is a star schema? What is a snowflake schema? Star schema, very simple, and which is used mostly these days. So a fact table is surrounded by multiple dimension tables, meaning, as I said, I will have one single fact table. The first section is called as key section. In the key section, it might be getting the data from multiple dimensions. So if you see here, I'm selling an product, an Apple iPad. So product dimension getting from product table. Organization, I'm selling it through e-commerce, I'm selling it through Amazon, I'm selling it to some other thing or an Apple store. That tells me what organization it is. Location, in India, US, time. So these are the four primary attributes which I'll categorize as product. So time dimension, location, organization, and product, and also the amount in the sales, in the dollar amount, which is important to me. So these dimension tables are the fact table is surrounded by multiple dimension tables inside a star schema. Any questions here, please?
One question. The facts, the sales dollar, right? They can come from any dimension. They
won't come from any dimension.
So they won't come from any dimension.
Because they are transactional data, sir. Your dimension table will contain the data which is not being changed. For example, if you take product dimension, what kind of data it might contain? If you take a guess, it will contain all the products which I am selling, right?
Yeah.
Organization, if you take, probably I am giving authorization to 4 companies, like one is Flipkart, one is an Apple store, one is Amazon store, something like 4 organizations I can sell my products. Locations, different locations which they are spread across, and time dimension. So these data will not change much, but your sales dollar will be changing. For example, in India it is rupees, you might buy 2 or 3. So it is a transactional data. It doesn't come under your dimension table. Okay. So I'll be taking the primary keys I'll be taking the key related information which I'll store in key section, and the dollar is just generated at that point of time. So if fact tables surrounded by multiple dimension tables will build a star schema. Vidya, you understood? Or probably you want me to repeat again? Okay. You did not understand? Okay, fine. I take no as not to repeat. The safer one. Okay, now snowflake schema. Difference between data modeling and dimensional modeling. They both are same. Okay. Dimensional modeling is done on tables. Of course, data modeling also done on tables. They both mean the same. Actually, they're not different. So now in a snowflake schema, you will have a little bit extended variety. So you see that extended boxes on the top of it. So inside a dimension table, I will be hitting regularly some attributes on a day-to-day basis, right? So if in a product dimension, I will have some important attributes which I need for every transaction. So those important attributes or those critical attributes, I will try to put them in a smaller section called as a lookup. A lookup contains the important attributes that are being pulled from a dimension table. If you take product category code, category name, and the date are the important attributes which I need for every join or every time I want to look up on a dimension. So those important attributes are stored in a dimension, so are stored in a lookup out of my dimension. And in a Snowflake schema, you will have fact table surrounded by multiple dimensions, and you will have lookups built on the top of these dimension tables. So there is a difference between a star and a Snowflake. So basically, Snowflake is what we prefer much because we use lookups a lot. Okay, we have a separate topic called as lookups in our ETL also. So a lookup is a kind of a view on the table. Basically, we are not hitting the complete table, but we are only picking the important columns, which we regularly deal with those columns, and we pick those columns and store the data in lookup. Again, is lookup static, persistent, or is it daily refreshed? So those things we'll talk about later, but here just a lookup is a lookup. Okay? Clear? Any questions? Kind of lookups, are they stored physically, are they stored logically, do they refresh daily? All these questions I'll take in the lookup section because that makes more sense there rather than here. Okay, any questions on star and Snowflake schema? Yes, sir. Okay. Fine. Probably when people can ask me in the next hour, I'm moving to the next topic. Now, what kind of dimensions are generally being used in our IT and data warehousing field? So there are three kinds of dimensions which we generally mostly use them. SCD, they're called as slowly changing dimensions. So SCD type 1, type 2, and type 3. There is type 4 also, it seems recently created. We are not using it much as of now, but if you want it, you can Google it and see what is type 4. Now, dimensions are primarily categorized as three: SCD type 1, type 2, and type 3. SCD type 1 is nothing but it's a pure overwrite, meaning I just delete all the data and insert new data. I don't store any history. Okay, that is SCD type 1, something like this. SCD type 2 is I maintain all the complete history of product. For example, what is the price in 2004, what is in 2005, what is in 2006, everything in detail. Right? So that is why I maintain SCD type 2. Now, what is SCD type 3? It maintains only the last successful transaction, only one history, past one. Okay? So SCD type 2 maintains complete history, type 3 with only one transaction, type 1 no history. That is how the three kinds of SCDs are built: type 1, type 2, and type 3. Okay? So this type 1, type 2, and type 3 will again study when we go to Informatica, because there is a topic called as Informatica Wizards where we try to create how do you do all these three things. Okay? Type 2 you can do with three different varieties, using a flag, using a date, using a version. So we'll study there in detail again. Okay? I'll be discussing only type 2. Probably when I discuss type 2, type 1, and type 3 are easy, because type 2 is the complicated one. How do we store history if you know it? Type 1 and type 3 you can determine on your own. But yeah, this again we'll cover in our mapping template wizards topic. Okay, we'll also cover, I don't know whether your content has it or not. We'll also cover dynamic lookup and non-dynamic lookup. I don't think it is mentioned somewhere. Okay, fine, probably. So dynamic lookup and non-dynamic lookup using SCD type 2. So how do you do the two varieties also I'll cover. Okay, so that's how the SCD type 2 are being derived. Any questions?
So what is this SCD?
Slowly changing dimension.
So that is SCD.
Yes.
SCD. Okay. Now, isn't all the dimensions slowly changing, or?
They're generally called by that, even though they're fastly changing or slow. Dimension is always slowly changing, sir. You cannot expect a daily or a monthly feed to a dimension table. It should be once in 2 months or once in 3 months, right? You'll not update a dimension daily. In no way.
Yeah, so like a address, right? Address changes probably once in a few years or whatever, right? Someone's address, right?
Once in a year, right? See, we address address is only one exception, right? So address feed generally we get it probably if you have a big customer base, and probably 1 week we process one address feed. That's it. Only once in a week. Only that to address and phone number and email. Or probably those things which we might change it, but other things we don't touch it regularly, right? So address is exception. Okay.
What is the faster changing dimension?
There is no faster changing dimension. That's generally called as solution dimension. That's it. There is no other way of it.
Oh, okay.
Any more questions, please? Okay. So this is what I've done. I have few more slides which talks about the ETL process. Probably I'll cover them as part of Informatica. Okay. I'll circulate this deck, or probably I'll upload it in the SharePoint or the one which Anthony creates. You can refer it from there. And that's it for today. Thank you. So probably any questions on a whole, on a bunch, you can ask me in the next class. And people who don't have their audio right, set up their audio, please. Probably interacting will be more easy. Yeah, Sandeep, I'll do that. Probably I'll send it to Anthony and Swaroop. They will circulate it to you.
Okay, I have a question on the software you're going to use for Power Center or Informatica. Now, is that
Sure, sir.
Is that the express version of it, or is the one which will load on the laptops?
Can you come back again? I lost it in between. The software which I load on your systems?
Informatica. Will that be the express version or of the client?
Informatica.
No, he's asking if it's going to be express version or standard version.
I'm doubting Informatica is an express version. You heard it about? I don't think so.
Informatica, if you go to site, you can download the express version. Anyone can download express version of the Informatica.
Okay, probably that's news to me. I'm not installing in express version. It's a regular edition, standard edition.
So now what
the one which I give is the standard edition.
So what we will download is just the client of Informatica, and the server will be from XcelFrameworks, or we'll also install the server?
So we'll also install the server on the machines, basically, both server and client. So I'll be sending you 3 links, sir. So one is an Oracle Express edition. So probably the one you see is on database. I don't think still an Informatica Express edition, but I'll definitely learn if it has. So this I'll provide you. This is an Oracle 10G version, which I suggest. If you want me to install on some other database, I'm ready. But this is a database Express edition. I suggest this version because it is mostly user friendly and it is thin client. It occupies less space. Right? So once you have Informatica installed, try to log into your respective laptop 5 or 10 minutes before. Every time I try to be on time, my laptop kills me because your laptop will become slow. And that to be the 8.6.1. If you want 9.1, you're gone because you'll have both server and client on your machines.
I already installed Informatica 9.1.
You already 9.1. So is it good? I mean, the performance is good. How is it?
It was okay. Not like a standard one,
Okay, probably. So this version of database, right, is much easier for creating tables or deleting data or creating more number of records because it is all on a user-based GUI basically. So graphical interface is there. I suggest this version. On the contrary, if people want to use stored or something like that, they can install their own. I can help you. But this is what we generally give it, and the Informatica 8.6.1. If people have different requirements, you can definitely reach to Anthony and Swaroop. I can install the corresponding softwares, but performance will be degraded unless until you have a very good RAM like 8 GB or something like that. Okay. So we go with 8.6.1 and Oracle 10G. That's the software I'm providing you. And Informatica standard edition. It's not any Express edition. Are we good?
Jairam, last question. Do you record the question that we asked in the sessions?
No, you can record the whole session, right? You're not doing it? In the options, there is record on this computer. So this records the whole session like a movie. Yeah, it's recorded. And I think he's going to put it in that SharePoint site, Anthony. Right, Anthony? All the recordings?
Okay, perfect. That's all I wanted. Thank you.
Yeah.
All the slides you have is something we can keep a copy, or we'll have to get it from.
You can keep a copy. I don't mind.
Yeah, because to revise stuff and all that, if you are preparing for interviews and stuff, to revise stuff, to go over the stuff, you know.
Sure, definitely. Yes, that is what you have. But generally, see, this is only class I go with PPT. What OS it is supported? It is supported on Windows 7 and Windows 8 both. Okay, both it supports. Basically, Windows 7 is easy. Windows 8 it takes some time. You have to set lot of things on Windows 8, but yeah, it supports on both the things. And PPT, I'll share it, sir. Definitely, I'll share it. And from next classes, it will be mostly the recording will help you. I'll not go through each layer of PPT. Okay, because I'll go through the tool more, and of course, whatever I've gone through the tool, it is present in PPT. PPT is something for you to refer, but I'll not go through each slide one by one. I'll just tell you the options in the tool, and probably the same thing are written in the PPT. So it's a kind of reference only. So mostly your recorded video will help you. That is the main thing which helps you going back. Yes, sir.
When you go through the tool, will everyone in the class will also be hands-on on the tool and trying to do the same as what you're trying to do on the tool, or?
Oh no, no. So once I go through the thread, probably I encourage you to go back at home and then try to do a hands-on. So if you try to do parallelly, it will create more mess.
Oh, okay.
So for example, I did one mapping today which load from, for example, a flat file to a table, right? So I give you this one and some more scenarios on it. So probably if you can spend half an hour, 1 hour back at home and try to do it, it will be more helpful. And at least half an hour you should be able to take off from your time. Otherwise, it will be difficult in catching up. By 1 week, you will have some 10 or 15 mappings to create and practice. See, I have approximately have around 100. You will be at least building 40 or 50 mappings on your own in your corresponding Informatica also. So that's how we go. So spend at least half an hour a day so that you can